given minimum percentage of changes between the old and the new password and stuff like that. We also acquired, together with PerfDat, a product called Service Control. We are in the middle of field testing the new TCP/IP stack version 10.5. This is available now, and the production version will be available around end of August this year. The next big topic is regarding the VMS port to the x86 platform. Actually, and I'm sure you already noticed it throughout the different media, we achieved first boot on May 14th, a bit later than expected, but finally we did it on May 14th. So work is ongoing, and we are pretty optimistic that we will see further progress pretty soon. On the VSI training side, we have launched a new self-paced online training program, which is available since May 30th this year. And you will see that we will continuously add new training material and short tutorial videos from time to time. We have also released a new Samba version, 4.6.2, in early June, and a new development environment is also now available. This serves as a state-of-the-art development environment on the Windows side, where you can create, edit, modify, compile, link your applications, and in the background, the compile and link stuff is done on the VMS side, but the front end will be using all state-of-the-art graphical features of a modern Windows PC. The final thing I would like to mention here is some news from HPE. I'm sure you all read the announcement that HPE has ended or will end all sales of VSI OpenVMS products the end of this month, that is June 30th, 2019. Okay, now we are slowly approaching the main focus of this whole webinar. We are talking about PerfDat. PerfDat is a product that has been created by HPE for an Austrian customer, and basically, this has been customer-driven from the very beginning. This is an integrated performance management tool that does not only show live performance data, but it offers many included features like collection data management, capacity planning features, and much more. A quite sophisticated alerting scheme, and more. PerfDat is available as a standalone product for your OpenVMS environment. And you can also acquire it as part of a VSI professional service offering where VSI consultants would do the capacity planning and the performance monitoring, or some troubleshooting and analysis of actual performance issues on-site or off-site, depending on the particular arrangements. Okay, before we jump right into my part of the demonstration, I would like to introduce myself. Actually, this should have been the first thing. My name is Thilo Lauer. I'm working since October for VSI. Before that, I had a 31-year career as a VMS consultant at HPE. And at VSI, I'm working in professional services. Having said that, I would like to switch to my slide set, because I also wanted to have a short theoretical part before we jump right into the live demo I would like to present you. this is the short agenda. We will have a short look at the design and the architecture of PerfDat. We will explain the different types of systems, the installation and configuration options, but in a very brief manner. Then we will enter the demo. I will show how to start-stop PerfDat. I will talk about so-called collections, how to define them, how to work with them. We will have a look at the very different modes of operation you can use PerfDat. We will talk about reports and reporting options, and we will do some online analysis. And the last two parts are talking about the stored procedure engine and the very sophisticated alerting subsystem built into PerfDat. This is almost an independent product integrated into PerfDat. The alerting subsystem allows you to use PerfDat as sort of a watchdog facility that triggers certain alarms on almost any condition you can imagine. But we will talk about that later. So what is actually PerfDat? This is a statement from the manual, from the PerfDat manual, and this is quite a mouthful. PerfDat is a performance and capacity planning solution that is capable of supporting all performance and capacity planning related activities during the lifetime of a system, which basically means PerfDat is not just a performance monitoring tool that is able to draw nice looking graphics and zooming in and stuff like that, stacking, unstacking. PerfDat is primarily a performance data management system. So what you get with PerfDat is a data management and archiving solution that does housekeeping as well. It will automatically create all sorts of reports based on the raw collection data. You can use it for online monitoring, of course. You can tune your system, you can troubleshoot particular performance issue, but you can also use PerfDat and its reporting feature to benchmark a system, to do stress testing, or to characterize a given system and see how it behaves over time. You can do capacity analysis, and you can use that feature to, for example, examine any performance impact of new application software or new OpenVMS releases or even hardware changes. As I said before, it has a very fine-grained alerting subsystem, and it has a Windows-based GUI, which will be the thing we will use later on during the demo. This is a huge list of components of PerfDat, which I will actually not go in detail through it. This is all existing in the online documentation. Of course, you have a data collection, a collector, you have a distributed performance database. But as I said, I will basically skip that slide as a picture is more worth than 1,000 words. So I would like to describe the PerfDat architecture based on that picture. So what you see in the middle, painted in red, is the performance database of PerfDat. This is a distributed database based on RMS indexed files, and this database is filled by either the OpenVMS data collector in the lower left side, or by one of two PerfDat extensions. We have an EVA extension collecting EVA performance data, and an SNMP extension where we would collect SNMP data provided by an SNMP server system. On the very bottom of the picture, we have the PerfDat configuration database, which keeps track of all the configured alerts and reports and profiles and what else. This distributed performance database can be queried from the VMS side, and this is drawn in yellow on top of the distributed performance database. You can apply all sorts of statistics on the collected data, and you even have an API available where you could enter, for example, application-specific performance data into this performance database. You can, of course, import and export data into and from CSV files. And you have a control interface drawn in the middle called PerfDat_Manager. This is a VMS utility which you will use to actually manage start, stop collections, define reports, define profiles, and so on. Let's talk about the different roles a VMS system or a PerfDat system can be in. Of course, it can be an OpenVMS collector system. This would mean this OpenVMS system has active data collections running. It could also be an archive system. An archive system is a system, as the name implies, that archives performance data from all nodes that are collectors and have this archive system defined as the target of those collection data. An access server is simply any server that has a particular data query interface running, which makes it possible to actually access the data. And we will later on access the distributed performance database via a so-called access server. Then we have an EVA agent system. This is, of course, a non-VMS system. It provides EVA performance data and feeds it into PerfDat. We have an SNMP agent system. This would be the VMS side receiving SNMP data. And we have an SNMP server system, which is the opposite. This would be the source of SNMP performance data. Some more concepts regarding PerfDat. The first concept is a PerfDat profile. This profile defines the characteristic of certain collections. For example, it defines the sampling interval a collection should run on. It also defines in very fine-grained detail what metrics it should collect. A collection itself is the process of actually collecting performance data, and its behavior is controlled by a previously defined profile. A report is a way of, well, massaging raw collection data into more advanced report formats. For example, you would use reports to smoothen out the raw collection data. Let's say you have a sampling interval of 1 or 2 minutes, but you want to do an annual report, so it's totally useless to have a 1-minute resolution of the report. So this is a way to highly compress raw collection data into very small reporting files. Now, the performance database is the sum of all those data files. It contains the raw collection data, but it contains the automatically created reports as well. When we are talking about metrics or elements in PerfDat, this would mean these are the performance classes and the particular items within those classes we are working on. For example, a performance class could be disks, and an item within this performance class or within this metric could be direct IOs or megabytes per second or stuff like that. Now the last concept I would like to talk about is the concept of a community. This serves as a way to logically partition your whole PerfDat environment. Let's say you have PerfDat running on 50 nodes in your IT department, but not all of those nodes are related to each other. Maybe only 8 nodes within your overall PerfDat installation are productive, so you would define a community containing just those 8 productive nodes. And maybe you would define a second community called testing, or a third community called purchasing department, or whatever. So this is nothing but a logical definition of similar or depending VMS systems. And you are totally free in defining what should participate in a given community. This has nothing to do with an open VMS cluster. You can have 3 communities in a 10-node VMS cluster, or you could combine 3 single-node systems into one community. So this is just a logical concept of restricting the view into the performance database. This is a short overview about the PerfDat installation, just to show what you will be asked, but we will basically skip it and leave it with the remark that it's a pretty straightforward PerfDat installation. No magic behind. The PerfDat startup could be via different ways. You could either use the DCL startup commands on the right-hand side, or within the PerfDat Manager utility, you could use the launch command to start specific parts of PerfDat. Okay, now at this point we will jump right into the demo, and I will leave the presentation. Just a second. So this would be the Windows-based GUI, and I will start in explaining the different parts and the layout of the GUI first. So in the upper left-hand side, you will see the available access servers I could use to connect to the performance database. And actually, this is what I will do right now. So I connect to my system IA22, use my VMS username. It's connecting. And right now, what you see under the collection view subwindow, you will see an expandable tree under IA22. It's an open VMS system. And this is actually what I defined as a community. So my community consists of the nodes IA22, 21, and 50. Let's have a look how the tree expands. You will see several collections, with the default collection, as the name implies, is the one PerfDat automatically has created during startup. Okay, so what we will do right now, we will create our first graph. To do that, I will have to actually load a particular collection. For this, I will click on the default type of collections, and in the lower left-hand side, you will see that about a dozen of single-day collections has opened. This is the amount of available collections I can further examine right now. And what I will do, I will take 1st of June. I will drag and drop it into the left one of the large windows. This is called the working set of PerfDat. Now you see in the working set the collection default from 1st of June with the following properties: sample interval 120 seconds. It started on 1st of June and it stopped on 2nd of June. And below that, with that expandable tree, you will see lots of matrices with lots of particular elements. Now for a start, I would like to choose just a few items from the system matrix, and I would go with, let's say, CPU load, and let's add cache hits, and maybe disk I/O. So I have selected the 3 elements I would like to see. Now if I right-click on one of the selected elements, I will get a context menu with several options. The one we are interested is new graph, of course, because we actually want to create a new graph, and we want to create it from the current element selection. So I'm clicking on current selection and changing the tab from the Data Explorer, which we are right now in, to Graphics. You would see a nicely colored graph showing 3 items. As you can see, they are labeled in the lower hand side. iCPU load is the red line, iCache hits the green line, disk I/O is the blue line. And of course, you now can do all sorts of fancy things. You can, of course, zoom in. You can, of course, scroll to the left and to the right. You can unzoom. And one thing in particular to note, if you look at the y-axis, you see different units. This is because each curve has got its own scaling. But if you don't like that, you can also use the scaling menu item and do a native scaling. So all the y-axis would have the same units. Okay, let's go back to the Data Explorer. Now what we want to do is we don't just want to have a look at one particular day. I would like to add 19th of June as well. And let's say yesterday in addition. So I have 3 random days, and I would like to compare, for example, let's stay in the system. I would like to compare, let's take MP-Sync. I would again do a right-click, new graph, current selection, and I would get one graph with just one curve, namely the MP-Sync from IA22 of 1st of June. Now I have several ways to actually compare the 3 days. I can, at first, I could manually add the same metric from the second system, MP-Sync, and not choosing new graph, but add data to graph. Again, the current selection, and I would get, hopefully, a second curve, which is true. Now, this could get a bit cumbersome, to be honest, if you have more than 3 days to monitor. So what you can do is you can again click on OpenVMS and the element you want to get display, do a right click, but now we want to create a new graph, not from the current selection, but from a series of data collections. And what you will see is the 3 days I just loaded in my working set, and I can freely define which collection should be included. So I selected all 3 of them. I click execute, and I get a nice looking picture with all the 3 graphs combined in one graphic without having to manually select them. You can also do something different. Let's say you want to have June 1st serve as some sort of a reference because you feel this is a normal day for you, this is a reference day. So you could define this day as a reference. Now, if you choose to look at another day's metrics or performance data, I'm sticking with MP-Sync again. So it's enough to just select this one, create a new graph from the current selection, and what will happen, PerfDat will automatically create this graph, but that of the reference day as well. So this is a nice feature to define a reference and just click one particular item to show compared with the reference data. Now let's have a look at live online data, because what we have looked right now is historic data. This is data from last month or maybe yesterday, but maybe you are interested in having a look at live online data. So I will first remove this data from the working set, and I will choose a different collection called THL_online, which I have particularly started with some flags to be online accessible. So I will choose today's metrics. I will again, or let's have a look at CPU and select all 4 CPUs. Let's choose kernel mode and get a new graph on the current selection. So I would expect a graphic with 4 graphs, which is true. So as you can see, this is a server being located at the East Coast at the US, and with a 6-hour time shift, we are somewhere just between 9 and 9:30, or maybe 10 o'clock we could zoom in. Clicking this red arrow, we will actually switch to online mode. And what happens now, every minute we will get an automatic update to that graph. And to see that in action, we will actually zoom in a bit. Wait a couple of seconds, which is okay for me to have a sip of water. The update interval, by the way, has nothing to do with the sample interval. This is purely controlled by PerfDat and the graph settings. So with this item, you can control the update frequency in minimum. So I've set it to the lowest value of 1 minute. So I'm not sure. You see, this is an automatic update in progress, and basically I would have to further zoom in, which I'll skip for now, but I think you have seen that the automatic update has been done. Okay, so far we only looked at raw performance data as it had been collected previously, but PerfDat has to offer much more. And this leads us to the concept of reports. In general, reports serve the purpose of highly compressing raw collection data. In addition, those reports will never get automatically deleted as it is done with raw collection data files. So what PerfDat offers is basically 4 different types of reports. The first, I will switch off online mode. The first we have been already using. This is a trend report. A trend report shows changes of system characteristics over time. So the raw data gets averaged and compressed. You have the option of different time spans, for example, day, week, month, year, year to date. And you would use it typically for a week or monthly reporting. The main purpose of a trend report is you would use it to detect changes of system characteristics over time. For example, you could compare the first week of every fiscal quarter. Now, the second kind of report is a capacity report. This one shows a daily workload with selectable busy time ranges. So what this means is you will get only one performance value for each element for a whole day. Now, not every hour of a complete 24-hour day is equally important to judge about the system's performance. So you could define the time span between, let's say, 8 a.m. in the morning and 5 p.m. in the evening to only be looked at for this sort of capacity planning. And you have a maximum of 5 time ranges available for those reports. This would be used for long-term capacity plannings. There are 2 more reports, baseline deviation, which you would use to define a baseline and to get a picture and an understanding of any deviation of that baseline reports. And the last one is a day-to-day deviation report. Combined with this, or to make use of the different sorts of reports, PerfDat offers several different GUI modes. The first is the one, it starts up by default. Let's switch back to Data Explorer. It's controlled via the mode menu item. By default, we are starting in short-term mode. This one works on raw collection data, and the data is presented on a daily basis. So in any case, you would see data for one day. This is useful for direct comparison, for example, Monday of each week. The emphasis is on short-term evaluation of performance data. Then we have the trend analysis. This one works on compressed data, and as with short-term analysis, data will be overlaid. The main usage is comparing system data. So we could switch to trend analysis. We would select, in my example, I would use the month of 1st of February and the 1st of March. And I would define 1st of February as a reference. For example, have a look at the item Let's choose free memory. Create a new graph. And you would see the comparison between the 2 months of the free memory of this system. The red line is March and the green line is February. The fact that it doesn't span the whole month is that these are our lab systems. They are rebooted very often, and I don't have auto start enabled for every collection of PerfDat, so I'm simply missing certain days of the collection. And this one serves the obvious purpose of directly being able to compare several months or weeks or quarters or whatever time span of different systems or of different time spans. The next one would be long-term mode or long-term analysis. And this does not allow any overlay of different intervals. It accesses raw data as well as reports, and its main use is for capacity planning purposes. So you would use it to examine the evolution of a system over time. And as I said, you would access reports that only create, let's say, one data item per element per day, because you are interested in long-term evaluation. Okay, I can do a demo of that one as well. We switch to long-term analysis. We look at IA24. We look at the year report, and we select the only one available. This is the long-term report since 1st of January. And again, look at my favorite, the system metrics and the CPU load. We again add a new graph, have a look at it, and you see a not quite dense graph, again due to some downtime of the system or PerfDat not having run for that time span. And what you see at the bottom, you see that it indeed started at around 1st of January, and it spans up to today. And it's somewhat smoothened. And if I zoom in further, you will see that indeed you will only get one data item per day. So this is a report that's basically used to see some long-term evolution. And you would also see this is not an absolute value, but this is a percentage. This shows you the deviation. No, I have to correct myself. This does not show the deviation. We are not talking about the deviation report. This is the CPU load as a percentage. So on average, we are at a constant 20% of the system's capability. Now, as we have already seen, we have a lot of metrics available. And if this is still not enough, you can easily define your own ones. So I'm going back to short-term analysis, and I will remove that one and choose another one. I will take the one from 21st of June. Now I could again have a look at the CPU load. And what this picture shows me is the CPU load compared against the total horsepower of that system. Now this system has more than one CPU available, but this graph doesn't take care of it. It just shows an absolute percentage. So you could think that at this point in time, you almost saturated the system because we are reaching 100%. So in order to create a new item that gets calculated, I have defined my own variable called CPU norm via my stored procedure engine. So in this window, you can define for every metric, let's switch to the system metric, any calculation you want to be performed. So what I did, I defined a new variable, CPU norm. I added the calculation that should be performed. So what I'm doing here is I will divide the total CPU load by the number of CPUs. And I could add a command, normalized CPU load. The unit is in percent. Clicking define, closing the window. I could now use that newly defined variable labeled by a sigma sign to show that's a calculated value. Now I can create a new graph. I'm sorry, I have to click OpenVMS. Look at the graphics, and you see the picture looks the same, but if you look at the scaling of the y-axis, it now shows properly from the total horsepower. We are somewhere between, let's say, 27 and 28% of the maximum of 100% CPU load. So this is a way to easily define own calculated values. Now, the last thing I would like to demonstrate is the feature of alerts. And therefore, I would like to switch to the VMS side on my lab system. Alerts, as I said, is a way to define certain thresholds for certain elements within PerfDat collections and to define the condition when PerfDat should spit out an alarm. The process of defining an alert is done via a config file. And what I will do now, I will have a look at my config file I have created for this demo. It's located in PerfDat$CFG and it's named thl_alert_openvms.cfg. Each alert block is surrounded by an add alert and end alert. Now let's have a look at the second alert block. What I am monitoring here is the used space on a particular storage device. The statistics to be monitored is I used. This corresponds to one of the many elements we have seen in the GUI before. The particular device I want to monitor is $1 DJ51. And to show the use of allowed wildcards, I used an opening square bracket because that's the way the devices are labeled in the GUI. Let's have a look at the PerfDat GUI. If I look into the metric device, you would see the device naming in PerfDat is the device name without colon, a square bracket open, then the label and the closing square bracket. And that's how I have to use it here. If I omitted the opening bracket and use the wildcard behind the 51, it would include DGA 510 or 511 or whatever as well. So using that syntax, I would restrict this alert block to exactly this device. I now define a warning threshold in percent. Here it is 10%, and I can define a critical threshold of 20%. I can also define an operator to be applied. So if the actual I used statistics is greater than this threshold, then spit out a warning. And if the actual measured statistics is greater than this value, spit out a critical alarm. So how does PerfDat actually inform me about the event? By default, it will use an opcom message, but you can also specify a DCL command procedure that gets submitted on a freely specifiable submit queue. Now, all we have to do is have to enable that alert within PerfDat. I enter PerfDat Manager, and what I will do is I will say enable alert, apply it to the collection thl_alert, and specify this alert file, PerfDat$CFG thl_alert_open vms.cfg. Now I have enabled the alerting for my collection, and I can control that via a show collection thl_alert. And what you will see in the middle, online alerting enabled, yes. And the alert definition file is the one we just had a look at, thl_alert openvms.cfg. That's all we are interested right now. Now we have to create a condition to have PerfDat spit out a warning. So what we will do is we will have a look at show device $1 $DJ51. And what you see, this is a device with roughly 56 gigabytes of memory, with 55 gigabytes being free. So there's almost nothing on there. So what I will do is I will waste some space on it, but first I will do a reply/enable. Now I do a copy nl/alloc equals, and now I have to be careful with the number of zeros. If my math is right, I need 6 zeros to $1 DGA51. Okay. Now my collection thl_alert has been started with a sampling interval of 10 seconds. And within my alert block, I specified that it will need at least the average over 2 successive samples to come to the conclusion that a certain threshold has been exceeded. So we have to wait 2 times 10 seconds to see a warning. And actually, this is the result of PerfDat alerting me of a certain condition. And what has happened is that the device capacity exceeds the warning threshold. The threshold value is 10%. The measured value is 11.74%. So this is the warning. Now, if I waste a bit more space, I would expect to get a critical warning. You see, this is the average it has increased, but it has not exceeded yet the threshold value for the critical warning, which was 20%. Okay, you see, this is the feature in action. This is about the very sophisticated alerting feature within PerfDat. And with that, I would like to actually close the demo and open the panel for questions. So let's see. I'm just looking for the questions panel. Okay, the question was, can the CPD files from Broadcom's Performance Advisor be read into PerfDat database? I haven't yet dealt with that tool. PerfDat in general has the capability of importing CSV files. So what you could use, for example, you could import T4 data or any other data that is readily available in CSV format. So the answer is basically, I don't know. We would have to have a look at it if we could manage to process that data and put it into a format to be digestible for PerfDat. Can workgroups be created using, say, process names? Yes, they can. What you can do is you can, and basically this is done automatically when PerfDat gets installed. You can examine the behavior of a certain process. You can also enable monitoring of file accesses within a certain process. You can even go down a bit further and have a look at certain images and their usage of system performance data. You can also have a look on certain devices and define critical files on devices and add certain application files, for example, to a list of files to be automatically monitored. So yes, this is possible. Yes, of course. Yes, this is a purchasable product. As I said at the beginning, you can purchase the product for, let's say, to use it standalone on your own. That is, you are buying licenses for 1, 2, 10 systems, or you buy a corporate license for 50 systems or whatever, or you would buy professional services from us to have us have a look at the capacity data, to create reports for you, and so on, to configure PerfDat. So this is the current VSI offering. Will there be a 3PAR extension available soon? The thing is, we did not yet manage to find a 3GL API interface to have easy access from within C or C++ to access 3PAR performance data. But of course, this is a very valid and very interesting question. Of course, EVA are a bit aged, to say the least, and 3PAR is the way to go. So we are definitely looking into this as we would like to provide a 3PAR extension for PerfDat. Yes. Let me disable this one. Of course, there are test versions of PerfDat available. They come bundled with a 10-day temporary license, but within those 10 days, you can use each and every feature of PerfDat. So if you are interested, just approach us, send us a mail. We would be more than glad to provide you a test installation of PerfDat. Other storage products, let's put it that way. We do not restrict ourselves to only think about 3PAR storage. But there's nothing particular in the pipe, so to say. So we are not actually working on an EMC version. What we are considering actually is to create a new GUI with which would use state-of-the-art graphics features, because the existing one is written in Visual Basic 6, and this is no longer supported as a productive platform from Microsoft. So if we wanted to change anything in this existing GUI, sooner or later we would have to port it to something supported, and that is something we are actively considering right now. We are collecting a set of basic features for the first version, and that's what we are concentrating our effort at the moment. And of course, to get rid of the HP logo when you fire up the PerfDat GUI right now. This is an interesting question. Are we planning to add a monitoring tool like Cockpit Manager? Now, from a technical standpoint, this would be very interesting, because we would then talk about a product that would monitor your system performance. It would provide a watchdog or alerting subsystem, and it would be able at the same time to monitor the overall state and events and whatever of your whole IT. Now, Cockpit Manager is not owned by VSI, so I think we would have to arrange with the creator and maintainer of Cockpit Manager. But at the moment, this is not our priority, because I think we have to do enough to make PerfDat state-of-the-art, talk about the GUI and the new GUI, create the new GUI, and this is where we are heading right now. We are not extending or thinking about extending PerfDat with new functionality, but thinking about the new GUI, thinking about extensions like a 3-par extension and stuff like that, but not regarding adding totally new functionality. So we still have some minutes to go. Are there any other questions? Of course, if there is any question after we finished the presentation, I would like to show my mail address. So, or just send a mail to info@vmssoftware.com or either directly to me. I would be more than glad to offer to answer additional questions anytime. Communities. Concerning communities, another question, could disks or CPUs or something else be part of a community, or system is the lowest possible element for community? Yes. Communities are always a collection of systems. The thinking behind is you have certain systems that share a certain application or serve as failover systems for the active one. So you want to compare systems behavior. When you want to compare CPUs, you have the features available within PerfDat. You can use one CPU as the reference, or you can select a group of CPUs and compare the CPU's behavior of Monday this week against Monday last week. So you already have that feature to restrict the look at certain CPUs, but regarding communities, this is at system level, yes. Okay, so if there are no more questions for now, I would like to thank you all for the time you spent with us. I would like to say goodbye for now. Have a great evening, a great rest of the day wherever you are. Take care and have fun with our products. Thank you and goodbye.